Hello Internet! Today we are going to be taking a look at GitHub Actions and OpenSCAD. So previously we built a model with SCAD, and now I want to tie that into GitHub Actions, publish an STL whenever you update your SCAD application, so it'll automatically generate the 3D model for you. And then this is sort of an example of what GitHub can do. It can render STL files directly in your browser, which means that if we get this working, we'll have a fully working like CAD environment entirely inside of GitHub. So that's the goal. That's what I want to create. So it means that you can basically design these anywhere you can write code, and I think that's cool. So this is what we've built so far. It's a super simple cube that we're just trying to keep things as straightforward as we can. So it's just a cube with a bunch of numbers etched into it so that you can have a dice. And then this has been added to here. So I created a new GitHub repository called SCAD examples. You can go here and grab it. And then inside of here, we have our designs, which is our design. And then I've also done a small amount of work to add a basic workflow template. So GitHub Actions uses workflows as your way of defining what it should do as part of this. So this is almost entirely just the default template for this. The only things that I've really changed are publishing the STLs, that I changed the name. And then the default also triggers off of pull requests. I've removed that. I only want this to generate files if you would ever update the main branch. So it changes to main branch. The idea is that it's going to automatically generate a pull request back to that branch. So anytime you make a change to one of the CAD files, it should automatically go and generate a model for you and then submit a pull request to your project automatically that you can then use to do that. And then just to make sure this was actually probably going to work, I installed OpenSCAD, and just that's as far as I've gotten. So we've changed this so that we have in apt-get install OpenSCAD. So we're installing that package, and we should be able to do everything else. You can see the next multi-line script thing is just stuff. So it's not actually doing anything. But that's all we need to do to actually make this work. So the next two things that need to happen here is we need to generate our models. So I'm probably going to create like a generated folder and then throw models into there. That means we're going to have to figure out how the CLI works. This is the documentation for OpenSCAD CLI. It looks straightforward, but I've never used it, so I don't actually know what's going to happen here. But this is what we're going to be trying to use. I think we should just need this -O to change where we're going to output a new file, and then we'll see. But I have not done this before. I don't know if this is going to work. We're just going to record and see what happens. So that's what this video is. So let's get started here and see what happens. So I think what I'm going to do is first swap this out for a multi-line string, so we can just delete this one. This bar is YAML syntax for a multi-line string. It's saying that the following indented string is a multi-line string. Otherwise, YAML is white space based, so this would actually, otherwise without that symbol, it would look like a new data format or a nested type or something like that. So we have this, and then I think the next thing is to do an OpenSCAD, and I don't actually know how to even get files into this thing. So we're gonna make that up as well. But I think we want to go into designs, and then I'm calling this the D6 basic.scad with an output of generated /d6 basic.stl. We can probably come back to this and do some sort of automated script to actually identify and generate all of these. So we could just find all of them and do this instead of having to iterate manually over all the files that we add. But for now, I'm just going to do this and see what happens. And then I'm going to throw in an ls of our generated directory. If it doesn't exist, we should probably create it. So make dir, actually, instead of doing a make dir generated, I'm actually just going to create it here. Generated. And this way I can add a README here that says don't add files here because they're going to get overwritten. So files in this directory. Whoa, that's not how you spell that. Are auto-generated. Changes may be overwritten. Make, oh, wait, hold on. My keyboard has decided we don't have an enter key. There we go. Make changes in designs instead. Neat. We can go back and change all this other stuff, but I think that'll get us at least a basic thing. So what this is doing, just so we kind of walk through and are all on the same page about this. I also haven't updated, again, I built this from a template, so I haven't updated any of the comments. But the name here is the name that's going to show up inside of GitHub Actions. That's how we're actually going to find this. Push is going to trigger whenever a push occurs inside of Git on this specific branch. So what that means is whenever I push to GitHub and it changes the main branch, this workflow is going to run. The workflow dispatch option means that there's going to be a button that I can click that will also trigger the job. The next one is just a definition of the actual jobs. There's one job and it runs in Ubuntu. And then that job has 2 steps. The first one just checks out all of our code, so we have that available. And then the next one does the installation and execution of OpenSCAD. And I think that's it. That's all that's happening right here. And then we'll have another step later on that would actually create a pull request back to our project. And I think that's it. So test STL generation. And so what I'm going to look for here is this should complete successfully, and this should output, this ls should show 2 files. It should show our README that we just created, and it should show the newly created d6-basic that we have there. If both of those exist, then I think we can just go right to the pull request and we're good. If not, we will need to change things because I don't know what's going on. This is the part that's probably going to break. So we're going to see what happens here. But if we go into actions, still running. So that's a good sign. We get here, it completed. So then the only other thing to check is all the way at the bottom here. It exists. So we have 2 files here. We have readme and d6basic.stl. That means that the command at least created something. We don't actually know what's there yet, but we have a file. And so that's important. That means that we can actually do something with this. So the next step is going to be similar to how I generate the World of Zero website. So if you're unfamiliar, this is the website. It's mostly just a way for like some of the descriptions and things to be more nicely formatted. The way this is all done, if you read some of the descriptions that I have for videos on YouTube, those get turned into blog posts on this site. So there should be one matching every single video, 1-to-1. So we can click into this and you'll see there's the video. And then here's a markdown formatted version of the description that has been parsed a little bit nicely, so you get fun code formatting and things like that. We're going to use exactly what's doing all of this to run everything else. So the way that's working is this automate or create pull request part of the action. So I'm going to pull this in and we can talk a little bit about what this does. So there we go. I missed a dash. There we go. Important here, white space matters. This is YAML formatting. So that means the spaces actually determine what this means as far as data goes. So we have to make sure that's correct. And then there we go. So what this is doing is grabbing our GitHub token. This is a special token that is part of GitHub Actions that gets passed into them. You can configure the what this token has access to, whether it can create pull requests, for example, or push code to your repository. Maybe review pull requests or close them, or open issues or comment on issues. Those kind of things, you can control all of that from permissions at the top of your action to determine what this token is able to do. And then we have a bunch of things that are talking about updating video files. That's not what's happening. This is generate STL CAD. Sure. And then that's the name of the commit message of what's going to actually happen, because we're making a commit to a branch, and then a remote bot user is going to open up a pull request with that commit as the contributor to our repository. So if you're using this for some bigger open source project, you'll want to use a user that has signed your CLA. Otherwise, you're going to get issues because that doesn't work. But this is the committer that we're going to use. We're just going to use the default GitHub committer, and then a generated user. And then we're going to create a custom branch for this. So in this case, it's automated video update patches. We can name this whatever we want. In this case, generated STL's workspace, I think will work. Delete branch is set to true, so it'll delete the branch if this gets merged. Title. Yeah, let's just call this generate job. Sure, that'll work. STL file with the generate files command. Okay, fine. This should be enough for us to actually test it. I'm tagging everything as automation so that it's separated from any actual people doing things. And I think that's it. So if this works, if I commit this and this actually works, update STL with pull request. All right, there we go. Commit this. And now this should run, and we should be able to actually use this to do some really cool things with, because this should end up kicking off a new job. And hopefully, if it works correctly, we'll have a new open pull request. And like we showed earlier with some of the Prussia stuff, GitHub supports rendering STLs in browser. So we should be able to actually see, as part of our code review, a sample of the generated STL that we're creating. So we can actually use those pull requests and see the 3D model that we're creating. Let's see if this works. It did not. What did I break? Okay. This is always the fun part of CI stuff. Command not found. I've done something horrible. What is it? Oh, that would be it. I mentioned white space. In this case, we added a dash here. That's not right. So it's trying to interpret the name of the command we gave it as a command, and it's not a command. It was interpreting that as part of the string, and then trying to actually execute those as part of everything. So that's why we got that error there. But if we change this now and address all those issues, hopefully, update named PR generator. I guess I'm really bad at naming, so we're making it up as we go. But hopefully, that issue should be fixed, and that means I think that we're at least getting pretty far in this. We had already run and generated all of our stuff. The only thing that didn't work is we actually hit this issue at the very end which would have been the step right before generating the pull request. So we should at least reach that point because we no longer have the thing that broke. So let's jump in here. And then if we look at our build, we can see it finished, and we now have a pull request open. We go into generate STL jobs. I can look at files changed, and there should now be this, a basic D6 STL. And I can look at the diff, but if I go to view file, does this show me? Yeah, there's our dice. So now I can see the dice that I'm generating from my SCAD stuff on GitHub, and I don't even need to do anything. I can just see all of this directly, which also means that I can make changes to this. So if I go here and generate this, so all the changes I've made have already gone to main. So the only thing that hasn't happened is I haven't merged in. Oh, I have. Oh no, I'm in the wrong branch. There we go. If I go back to main, it doesn't exist anymore. Perfect. All right, we're a little bit all over the place, but there we go. We're back to main. And so if I go into our generated files, there is just this one README. So our generated STL doesn't exist on main right now. But what I can do is I think if I hit control period, or just period, there we go. That's going to open up GitHub's web editor. So period on GitHub will open up a web editor version that you can actually use. It's basically a embedded version of Visual Studio Code. And we can use this to go into our SCAD file. And again, entirely in my browser. I could do this on my phone if I wanted to. And then I can go in here and say, instead of 1, 2, 3, 4, 5, 6, we're going to switch these out for letters. So A, B, C, D, E, and F. And then we're going to save this. And then we're going to call this use letters in dice. Cool. And so if I commit this, again, keeping in mind, entirely inside of my browser, I can do this anywhere. We commit this. And now if I go back to my project, like this, go to repository. So to do that bottom left, go to repository. We can see that our job is currently running, but if I look at this pull request, it should get updated in just a second with our new file. So if I open this and do view file, our action is still running. There we go. Once this finishes, our pull request is actually going to get updated with all of these changes. So we're not going to open a new one because we already have an existing pull request open for these changes. So this should just update this. So if I go and look at this, we can see that another change was made, was force pushed over the previous one with the new changes. And we can see inside of here that if we go and view these files, we now have our dice with actual letters now. And so we can just use this to test STL stuff entirely from our browser. This is cool. And it's doing exactly what I'd hoped it would do. So yeah, that's that. The cool thing with this is this should work for forks too. So if I fork this into this channels repository as well and create the fork there. So now I'm in the forked version. It pulled in the GitHub Actions as well that are already set up for this. So let's jump back into an editor here. Again, still in the browser. So now I'm in a separate fork, doing my own thing, basically just relying on the pre-configured jobs. I can go into here and I want to revert these. So I could do a revert, but we're just going to pretend like I remember what I typed. And there we go. So 1, 6, 5, 2, 3, 4. This is just so that they're opposites and equal to 7 on all opposite sides. And then we can just do revert to numbers on dice. And now this is in my fork of this. I'm making this change only on my fork. But all of the GitHub actions are still applied to this repository, which means that there's now going to be a pull request open against my repository, my fork of this. I think. I haven't tested this. Okay, this is giving a warning because it's a fork, and because I'm cloning a fork or making a fork of a project, it's not running the workflows here. I'm going to enable them. And then if I go into publish STLs, it didn't run because we hadn't enabled them when the trigger happened. Since I have that dispatch, that workflow dispatch, you can see we have this little message here. I can run that manually just by clicking run workflow like this. And so it's now going to go and run that workflow automatically for us. And we should, hopefully, see this run and publish a pull request back to my local fork. So you can actually like keep working on this and keep doing things. Doing the enabling of forks and enabling of workflows like that might not be something you want to always do. It means that if you synchronize your fork, you might pull in jobs that you did not want to pull in that could do weird things on your code. So keep that in mind. But for what I'm trying to do, where I just want a template project more or less, where I can go and create a template of this, and then now I have a working thing that I can create STLs of. There we go. There's our thing against my current local version of this. So now I have another pull request open. This one is only going against the fork that I created, so against my personal project. And we can see it's back to numbers. Anyway, this is a really weird tangent that we're on, but it all works. So we can use this to kind of generate entire SCAD or STL files from code entirely in GitHub. The last part of this entire demo did not need any local files whatsoever. So you can use this as sort of a entire environment for just doing SCAD stuff if you want. I don't know if that's actually practical, but it's cool. So there we go. If you want to play with this, go for it. I'll leave a link to the main repository for this somewhere, so you can grab it and see how it all works. If you do try this out and build something other than a dice, let me know. But yeah, I think that's it for this video. So thank you all for watching, and I hope to see you in the next one. So until then, see you, Internet.